lesson covers the probability of simple events. Number 1. A number cube with faces labeled from 1 to 6 will be rolled once. The number rolled will be recorded as the outcomes. Give the sample space describing all possible outcomes. So when you roll the dice, I got some dice here for you. When you roll a dice, it's got the numbers 1 through 6 on the sides of the dice. So you got the possibilities of 1 through 6 when you roll the dice. Then it says give all the outcomes of the event of rolling a number from 2 to 4. So I highlighted that for you. So when they're saying from 2 to 4, it includes the number 2 and 4. So 2, 3, and 4. So any number from 2 to 4. It didn't say the word including, but they meant it. Number 2. A bag with 10 marbles is shown below. A marble is chosen from the bag at random. What is the probability that it is gray? Well, there's 2 of them that are gray out of 10 marbles, so 2 out of 10 are 1/5. And now remember, your calculator will reduce fractions for you if you're not good at it. So turn it on here. 2 divided by 10, hit math, enter, and it changes it to a reduced fraction, 1/5. Number 3. A 6-sided die with sides labeled 1 through 6 will be thrown once. What is the number? Each number is equally likely to be rolled. What is the probability of rolling a number less than 5? So they're not including the 5. Any number less than 5. I have to roll dice for you again. Okay, ooh, look at that. I got a pair. Nice. All right. So number less than 5. So again, that doesn't include 5, so that'd be 1, 2, 3, or 4. So that's 4 numbers out of 6 numbers on a dice, which reduces to 2/3. Next one. A basket is filled with 8 white eggs and 10 brown eggs. Half the white eggs are cracked. An egg is randomly selected from the basket. What is the probability that it is cracked? It is a cracked white egg. Write your answer as a fraction in simplest form. Well, there's 8 white eggs out of a total of 18 eggs. 8 plus 10, 18. So what's the probability? The probability is always out of the total, and our total here is all of the eggs in the basket. So there's 8 white ones out of 18, and then half of them are cracked. So times a half, and so that gives you 8 over 36, which reduces to 2/9. Again, we'll do it on the calculator. So 8 divided by 18, and then times a half, and again hit, times, not divide. No, I did times. And then change it to a fraction, so math, enter, and you get 2/9. Next up, here is a table showing all 52 cards in a standard deck. I got cards for you. So, just for fun here, for those that have not looked at cards, Jack, Queen, and King are face cards because they all have faces on them. There's a King. There's a Queen. And there's a Jack in here somewhere. But anyway, you should buy yourself a deck of cards. It's fun. You can make yourself houses out of the cards. I don't know if you've done that or not. Back in the time before the internet, we did all kinds of crazy things. Let me tell you. You can learn how to shuffle really well, impress your friends. Anyway, so we got 4 different suits in a deck: hearts, diamonds, spades, clubs. Let's see, there's a heart, here's a spade, here's a diamond. What are we missing? I think, we're missing the club. So there's a club. So diamonds, spades, clubs, hearts. All right, so they'd like to know on number 1 here, on letter A. What is the probability that the card drawn is a spade? Well, there's 4 different suits, so you're going to have 1 in 4 chances. Or if you want to overachieve, you've got 13 spades out of a total of 52 cards in a deck. So that would reduce to 1/4. Next one, what's the probability of the card being a 2? Well, that'd be 1 out of 13 cards in a suit. Or if you want to, you could say there's 4 2s out of a total of 52 cards, which is also 1/13. Next one, what is the probability that the card drawn is a spade or a 2? Now we kind of do need the table for that. So a spade or a 2. I circled clubs. All right, so a spade, there's 13 of them. Or a 2. So then there's one that's a 2 and a spade. So then there's 3 other 2s. One's a heart, a diamond, and a club. So anyway, add them up. You got 13, 14, 15, 16 out of 52 total cards, which is 4/13. All right. Next one. A wheel has 10 equally likely sized slices numbered from 1 to 10. Some are gray and some are white. The slice numbered 3 is gray. The slices numbered 1, 2, 4, 5, 6, 7, 8, 9, and 10 are white. The wheel is spun and stops on a slice at random. Let X be the event that the wheel stops on a white slice. Let P of X be the probability of X. Let not X be the event that the wheel stops on a slice that is not white. And let the probability not X be the probability not X. For each event in the table, check the outcome or outcomes that are contained in the event. Then in the last column, enter the probability of the event. So the event X, and the X was that it stops on a white slice, happens all of them except for on the 3. On the 3 it was gray. So not being white was 1 out of 10 slices. So 9 out of 10 of them were white, and then 1 out of 10 of them was gray. Letter B, they want you to do 1 minus the probability of not X. Probability of not X we got was 1/10. And so that's 9 out of 10. So 1 minus probability of not X is the same thing as the probability of X up here, 9/10. All right, the spinner below shows 10 equally sized slices. Ma spun the dial 25 times and got the following results. So she got gray 8 times, white 10 times, and black 7 times. Fill in the table below. Round your answers to the nearest thousands. So that's 3 numbers. To the thousands is 3. From Ma's description, compute the experimental probability of landing on black. So the experiment would be what she did here. So the experimental probability of landing on a black is 7 out of the total, which was 25, which when you divide gives you 0.28, and they wanted it to the nearest thousands, so make sure you put a 0 in there, else the program will mark you wrong. Assuming the spinner is fair, compute the theoretical probability of landing on black. So we're not using the chart now. What is just the probability of it? Well, the probability of landing on black, there is 1, 2, 3 of them out of 10. So it's 3/10 or 0.3. Again, put some zeros on it so you have it to the nearest thousands. And that's 3 decimal places. And then last of all, as the number of spins increases, we expect the experimental and theoretical probabilities become closer, although they might not be equal. And we talked about this before, will be in another lesson. The larger the experiment, the closer you get to the actual answer. And we've discussed that like in terms of the COVID virus. They haven't had enough cases of it. Well, they've had cases, but they haven't done enough studies of people taking like the different drugs, the malaria drug or the autoimmune drugs, to decide which drugs really work. They've got to come up with more cases to study. Next one. Greg won a charity raffle. His prize will be randomly selected from the 9 prizes shown below. The prizes include 4 rings, 1 camera, and 4 headsets. Letter A, find the odds against Greg winning a ring. Okay, so they've changed it to the word odds. So we're not finding the probability. If we're going to find the probability of it, winning a ring would have been, let's see, there's 4 rings out of 9. So the probability would have been 4 out of 9. But they would like the probability against him winning a ring. So that would be not winning to winning. Not winning, there's 5 ways not to win to 4 ways to win with a ring. We want to win a ring. So then there's 4 of them, and there's 5 that are not a ring. So the odds of it are 5-4, or 5/4. What's the odds of him actually winning a ring? Well, that'd be him winning to not winning. So again, there's 4 rings to win and 5 not to win. So the odds in favor of winning the ring are 4-5. And again, against it, there's 5 ways not to win it to 4 ways to win it. So 5-4. Maria is playing a role-playing game with her friends. She will roll dice to determine if her character casts a spell. The odds in favor of her character casting a spell are 11-8. So 11 to 8 would mean there's a total of 19. We saw that on the other side with the rings. 5 to 4 would be a total of 9 when you add them together. So the whole thing was out of 9 for the probability. So to figure out the whole probability of the total sample space, you just add together the two numbers and the odds. So if these were the odds, the whole probability space would be 11 plus 8, which is 19. So the probability of her, since it was in favor of it, that means 11 ways that she can win. So 11 out of 19 would be the probability. Next up, a child has a box of colored building blocks. If she chooses one block without looking, the probability of choosing a green block is 6 to 17. What are the odds against choosing a green block? So again, add the two of them together, and that would be the total amount of blocks, or the other number of blocks there is 17 minus 6. There's 11 there that are non-green. So 11 to 6. So 11 to 6 would be the odds against winning it. Oh, shoot. So, all right. I read it wrong. So the probability. So anyway, I'm so sorry. So going back from the top here, there's 6 green to a total of 17 blocks. So the number of blocks that aren't green are 17 minus 6, or 11 non-green blocks. So this was a probability, not the odds. Sorry. So again, that makes it 11 to 6. Okay, another card question. So they'd like to know on letter A down here, find the odds against drawing a club. Well, against drawing a club would be a not a club to how many are clubs. Well, there's 3 suits that aren't clubs, spades, diamonds, and hearts, to 1 that is a club, so 3 to 1. Find the odds in favor of drawing a 10. So drawing a 10 to not drawing a 10. There's 4 ways to draw a 10 to 48 ways not to draw a 10, or 1/12. All right, number 11. A dart hits the circular dartboard shown below at a random point. Find the probability that the dart lands in the shaded circular region. The radius of the dartboard is 6 inches. The radius of the shaded region is 2 inches. Use 3.14 for pi. Round your answer to the nearest hundredth. So we want to get the dart into the shaded middle area, and then want to compare it to the whole entire dartboard, including the shaded area. That's because they want the probability, so it's to the whole space. I think we both know that they need to take into account that we might not even hit this part here. Wow, yeah. So I don't know if that's really going to be the probability of it, but anyway. So the small shaded one, so that's the area of the circle to the area of the whole entire circle. So the small circle, pi r squared, is the area of a circle. To the whole giant circle, pi r squared. Well, what's fun is we can cancel the pi's out. So all we have to do is compare the smaller radius of the inside circle, 2 squared, to the whole entire circle's 6 squared for the radius, which is 4 out of 36, or 1/9, which is 0.1 repeating, so that the nearest hundredth is 0.11. Number 12. Izzo's Pizza sells 4 types of pizza crust. Last week, the owner tracked the number sold of each type, and this is what she found. Thin crust, 328. Thick crust, 227. Stuffed, 169. Pan style, 301. So I added them all up. If you add all 4 numbers up, they total 1,025. So based on this information, of the next 2,500 pizzas she sells, how many should she expect to be a thin crust? So, on the experiment here, she sold 328 out of a total of 1,025. So this was the experimental number over here. So, I'll write experiment on it. So, she's going to use, based on her experiment, if she sells 2,500 next week, how many can she expect to be thin crust now? So that was thin crust out of the total. Out of the new total, though, then what is it? So again, we're going to cross multiply and divide because it's a proportion. A fraction equal to a fraction is a proportion, and you get 800 pizzas. All right, number 13. Lisa is playing a game of chance in which she tosses a dart into a rotating dartboard with 8 equally sized slices, numbered 1 through 8. The dart lands on a numbered slice at random. This game is this. Lisa tosses 1 dart. She wins $1 if the dart lands on a slice that's 1. $2 if the dart lands in slice 2, $5 if the dart lands in slice 3, and $8 if the dart lands in slice 4. She loses $2.50 if the dart lands in slices 5, 6, 7, or 8. Letter A, find the expected value of playing the game. Okay, so expected value is used to predict how much money you might win or lose. So, what you do to find the expected value is you multiply the probability times how much you might win for each and every single type of event that occurs. So, for example, on the problem that we're on, the first one here, landing on the slice 1 happens because it's numbers 1 through 8. It's going to happen 1 out of 8 times, and if we land on it, we win $1. And then if we land on a 2, again, the chance of that is 1 out of 8. We win $2. Then we win $5 if we land on slice 3, which is also 1 out of 8. So the probability times the expected win each time. So expected wins 1, expected win 2, expected win 5, and then we expect to win 8. And each time we're just landing, the probability of landing on one of those slices is 1/8. Last of all, though, if we lose, we're going to lose $2.50 if we land on a 5, 7, or 8. That's 4 out of 8 is the probability of that. So if you do the math on that, you get $0.75. So Lisa can expect to win $0.75 per toss. So that's definitely a game we want to play. I'll put it in my calculator for you. I would put the thing in my calculator all at one time. So let's see, 1/8 times 1 plus 1/8 times 2 plus 1/8 times 5 plus 1/8 times 8 and then then we got a minus, so minus 2.5 times 4/8 or a half, whatever you want to enter, and 0.75. All right, number 14. Okay, Arthur was asking about this one. Hi, Arthur. Number 14, Digitalis is a technology company that makes high-end computer processors. Their newest processor, Loot A, is going to be sold directly to the public. The processor is to be sold for $2,800, making Digitalis a profit of $452. Unfortunately, there's a manufacturing flaw, and some of the processors are defective and cannot be repaired. Of these defective processors, Digitalis is going to give the customer a full refund. Suppose that for each Loot A, there's a 12% chance of being defective and 88% chance that it's not defective. So we want to figure out the expected amount that Digitalis can expect to win or lose here on selling their parts. So 88% of the time, or 0.88, they're going to make money, $452, and then 12% of the time, 0.12, they're going to lose money. Now they don't lose the whole $2,800 because they have a profit of $452. So that means $2,800 minus $422 is the actual amount of money they're losing each time, which is $23.48, because they make a profit on each one of $452. So they're not losing all of that. All of that's not a loss. What they're losing is this amount. When you subtract the two numbers, that's how much they're losing. And when you do the math on it, you get a positive number of 116. So they'll make on average 116 each time they sell one. All right, number 15. There are 16 girls in Mr. Alvarez's class. Recently, he took 20 from his class on a field trip. Of these 20 students, 3/5 were girls. Use this information to answer the questions below. All right, so 3/5 of 20, 3/5 times 20, I canceled 524 times, and 3 times 4 is 12, so there's 12 girls that went on the trip. And if there were 20 students that went, that means eight boys went on the trip. So 12 girls went and 8 boys did. So how many boys did not go on the field trip? I don't know. They didn't tell us anything about not going on the field trip, or even how many total students are in his class, so we can't figure that out. So letter B, how many girls from the class trip did not go on it? Well, they did tell us all the girls in the class. There were 16, and we know 12 girls went, so 4 of them didn't want to go. How many girls from the class went on the field trip? Well, we know that. That was 12. Number 16. An organization will give a prize to a local artist. The artists will be randomly chosen from 7 painters, 4 sculptors, and 5 photographers. What is the probability that the artist chosen will be a painter or a photographer? So they have the word or, which is union, and that's everything. So we want all the painters and photographers. So 7 painters and 5 photographers are 12 out of the total artists, which were 7, 4, and 5. So that reduces to 3 fourths. So as you can tell, if you've been watching the whole thing, the questions are now repeating with new numbers and just some new words, but it's the same questions again. All right, if you need some more help, please reach out to me by email or a text, and we'll set up some office time. Have a good night.